applications and problem solving. Step 1. Read the problem probably 2 or 3 times. Make sure you understand what is being asked. Step 2. Determine the unknown quantity or quantities. Assign a variable to represent the unknown. Express any remaining unknown quantities in terms of the same variable. Step 3. Create a table to organize the information. This will help you build your equation. Step 4. Solve the equation for the unknown and then answer any other questions. Step 5. Check your answer with the facts presented in the problem. In our first example, we'll look at the simple interest formula. I equals PRT, or interest equals principal times rate times time. A bank loaned out $12,000, part at the rate of 8% and the rest at 18%. If the interest received was $1,000 total, how much was loaned at 8%? It's always best to identify what we don't know first. That's going to be your variable. So pick out one thing that we know nothing about to let X represent that unknown. In this case, we know nothing about how much was loaned at 8% and also how much was loaned at 18%. So just pick one of those. X is the amount at 8%. So if we let X represent the amount at 8%, then we have to figure out how do we represent the amount at 18%. We know that there's $12,000 total loaned out. Part of that, X, is loaned out at 8%. So whatever 12,000 minus X is, that's going to represent the amount at 18%. And we know the total interest is $1,000. So looking at our formula, I equals PRT, let's set up this equation. We know the interest to be $1,000. The principal is in 2 different spots. We have one principal at X at 8% and one principal of 12,000 minus X at 18%. So we'll just pick one of those. The first one is 8%, so X times 8% times 1 year. And then we'll add another PRT. The principal on the second amount is 12,000 minus X times its rate, 18%, times its year, 1. Now we just need to simplify. 1,000 equals 0.08x. Then on the next PRT, we'll distribute. 12,000 times 0.18 is 2,160. And then minus 0.18x. In the next step, we'll combine like terms and subtract over the 2160. So on the left, we get negative 1,160 equals negative 0.1x. Divide by negative 0.1. And x is equal to 11,600. And we're talking about dollars. Now we just need to make sure that we've answered the question. The question is, how much was loaned at 8%? Well, we just found that because X we defined to be 8%. So $11,600 was loaned at 8%. Now be careful. Typically, questions like this actually want both pieces of information. So another potential question would be, how much was loaned at 18%? To do that, we simply look at our other initial condition, 12,000 minus x. 12,000 minus 11,600 would give us the $400 at 18%. Glenn requires $5,000 per year in extra income. He has $70,000 to invest and can invest in bonds paying 8% per year or in a CD paying 5% per year. How much money should be invested in each to realize exactly $5,000 in interest per year? Let's start again by identifying what we know nothing about. That will be our variable. So X, we don't know how much is in bonds. Amount in bonds. And remember, bonds are 8%. The other unknown is the amount in CDs. We know the amount in CDs is 5%. So how do we represent the amount in CDs? We know that there's $70,000 total to be invested. Part of that, X, is being represented by the 8%. So that means whatever 70,000 minus X is will be the amount in CDs. So again, we're going to start with our I equals PRT formula. The interest in this example needs to be $5,000. And the principal, notice we have two different principals, one at 8% and one at 5%. The first one, X, times its rate of 8%, times its time, again, we'll assume 1 year. And then we're going to add that to another PRT. The principal for the other option is 70,000 minus X, multiplied by its rate, which is 5%, times its year, which again is 1. And now we just need to go through and simplify our equation. 5,000 equals 0.08x. Distribute the 0.05 and we get 3,500 minus 0.05x. Combine like terms and we'll also subtract the 3,500 over. We'll get 1,500 equals 0.03x. Divide by 0.03 and we get x is 50,000. And now we just need to make sure we answer the question. This question is how much money should be put into each account. X we found to be $50,000. Which one is that? Go back to what we did at the beginning. We labeled the bonds as 50,000. So bonds is $50,000. And then the other option was CDs. CDs we labeled as 70,000 minus X. 70,000 minus 50,000 is 20,000. Next, we'll look at mixture problems. A chemist has 36 ounces of a 35% acid solution. How much water should be added to reduce the strength of the acid to 30%? Right, so always start by labeling what we don't know. X is the amount of water. So we need to know how much water to add. To set this problem up, when we're given a mixture problem, I like to use pictures. We have a container initially with 36 ounces in it, and it has 35% acid solution. And we want to add water to that. So we're going to add some water to it. How much water? We don't know. So we'll call it X. We don't know how much water to add. Now we want to talk about the acidity of water. In this case, we're going to assume the water has 0 acid in it. And then we want to get a result. We want that resulting container to have 30% acid solution in it. But what about the volume of that liquid? It's going to be, in this case, 36 plus X. And so now to create our equation, we're simply going to take the volume times the acidity and see what the result is. So here we're going to multiply 36 times 0.35 plus X times 0% equals 36 plus X times 0.3. And there's our equation. Let's go through and simplify now. 36 times 0.35 is 12.6. X times 0 goes away to 0. 36 times 0.3 is 10.8 plus 0.3x. Subtract the 10.8 to get 1.8. 1.8 equals 0.3x. Divide by 0.3 and we get 6. What does 6 mean? 6, we said earlier, X is the amount of water, which is what we're looking for. In this case, we need to add 6 ounces of water to obtain the desired solution. In our next mixture problem, we have cups of OJ. How many cups of a 15% OJ solution must be mixed with a 30% OJ solution to generate 10 cups of a 25% OJ solution? So again, at the beginning, I like to label what we don't know. What are we looking for? We're looking for the amounts of the 15% solution. We're starting with an unknown amount of 30% OJ solution. So we don't know the volume yet. We're adding something to it. We're adding how many cups of a 15% solution, so we don't know that either. And we want the end to be 10 cups of a 25% solution. So the part we're adding in, we define to be X. So I'm going to label this container as X. Its volume is X cups. That means this initial amount we can algebraically determine. We don't know exactly what it is, but we know if we add X to it, we get 10. So this container must be 10 minus X. So we're starting with 10 minus X cups. If we add X cups to the 10 minus X, we end up with 10. And now to create the equation, we're going to simply multiply down. Multiply these. 10 minus X times 0.3 plus X times 0.15 is equal to 10 times 0.25. And now we have our equation. Let's go through and simplify the equation, solve for X. 10 times 0.3 is 3, minus 0.3x plus 0.15x equals 2.5. On the left, we can combine like terms. We'll get negative 0.15x and then bring down the 3. Subtract 3 on both sides. And then finally, we'll divide by negative 0.15. And we get x is 3.3 repeating. 3.3 repeating is 3 and 1/3 cups. So we need to add 3 1/3 cups of the 15% solution to the original 30% solution to obtain 10 cups of a 25% solution. Uniform motion problems. Recall the formula D equals RT. Distance equals rate times time. We're always going to be using some version of that equation, D equals RT. A motorboat heads upstream on a river that has a current of 3 miles per hour. The trip upstream takes 5 hours and the return trip takes 2.5 hours. What is the speed of the boat? Again, we'll identify what we know nothing about, in this case, the boat speed. And when we talk about boat speed, think of that as the speed of the boat in still water. Assume the water's not moving, in this case, the boat speed in still water. Now let's create a table. We want D, R, and T. First, let's determine what's going on. In this case, they're going upstream and downstream. You could say with the current or against the current. It doesn't matter what you label that as long as it makes sense to you. Now, 2 of the boxes typically are explicitly stated in the problem. So let's look and see which 2 things are explicitly stated. It says the trip up takes 5 hours and the trip down takes 2.5 hours. Notice those 2 things are explicitly stated. The next 2 boxes will typically involve X, in this case, the boat speed. So we know the speed of the river is 3 miles per hour. If you're going upstream, you're fighting the current. So you have your speed, X, minus the speed of the current. If you're going downstream, you have your speed, the boat speed, plus the speed of the current. And then the final 2 boxes will always come from the formula. In this case, D equals RT. So we simply look at the table and multiply these. So we have 5 times x minus 3. I'm just going to reorder it to make it look a little prettier. But we're simply multiplying the 2 boxes. 2.5 times x plus 3. So 2 boxes are typically explicitly stated. The next 2 boxes involve the variable. The last 2 boxes will always come from this equation. Also, the last 2 boxes are what we're going to use to create our equation. What do we know about the 2 distances? If you're going upstream to a destination and then returning back home, then the distances are the same. So let's put those equations equal. Make them the same. 5 times x minus 3 is equal to 2.5 times x plus 3. And you have your equation. That's by far the hardest part, is just setting that up correctly. Now we need to solve. 5x minus 15 is equal to 2.5x plus 7.5. Subtract 2.5x on both sides. Add 15 to both sides. Divide by 2.5, 9. So that means x, the boat speed, is 9 miles per hour. In our next example, a motorboat maintained a constant speed of 15 miles per hour going 10 miles upstream and returning. The total time was 1.5 hours. Find the speed of the current. So label what we don't know, in this case, the current speed. Set up a table. We have D, R, and T. Let's label the two things that are happening in this problem. And again, we're going upstream and downstream. Two boxes are typically explicitly stated. In this case, the distances are both 10. We know that we're going 10 miles up and 10 miles back down. The next two boxes typically involve the variable, in this case, the current speed. We know that the boat speed in still water is 15 miles per hour. So if you're going upstream, you're fighting the current. 15 minus the current speed, x. If you're going downstream, you have the boat speed plus the speed of the current. The last two boxes will always come from the equation, d equals RT. But in this case, we're trying to find time. So let's just solve that equation for time. T is equal to d over r. So let's take our two pieces of information here and plug it into this equation. Time is d over r. So we have 10 over 15 minus x and 10 over 15 plus x. The last two boxes will always be what we use to solve the equation and set up the equation. So what else do we know about time? We know that the total time is 1.5 hours. So if we know the total time is 1.5 hours, then we can add the two times. 10 over 15 minus x plus 10 over 15 plus x is equal to 1.5. Setting up the equation is the hard part. Now we need to solve our equation. Notice it's a rational equation, so we need to multiply by the LCD. So in this case, the least common denominator is 15 minus x times 15 plus x. We're going to multiply every term by the LCD. 15 minus x, 15 plus x. We'll do that on the second term as well. 15 minus x, 15 plus x. And then the right side of the equation. And we can cancel. 15 minus x goes away in the first term. In the second term, 15 plus x goes away. And then on the far right, nothing cancels. So as we distribute, we get 150 plus 10x plus 150 minus 10x equals 1.5. I'll leave 1.5 for now and distribute the binomial. 15 times 15 is 225. Then we get 15x minus 15x, those cancel, minus x squared. Combining like terms on the left, we get 300. The 10x's cancel. Now we can distribute the 1.5 to get 337.5 minus 1.5 x squared. Subtract the constant. We get negative 37.5 equals negative 1.5 x squared. Divide by negative 1.5 and we get 25 equals x squared. Square root of both sides, x is 5. Make sure we answer the question. The question is find the current speed. We labeled x as the current speed, so it looks like we found it. 5 miles per hour is the speed of the current.